welcome you all to this online Math with Mr. C. And today we are looking at one of my favorite aspects, that is Euclidean geometry. And I have noted that the proof of a cyclic quad, more often it is misunderstood. So we want to highlight some of the features that we have here. So with me here, I have a question which says that prove that CEFD is a cyclic quadrilateral. The first thing is you cannot prove that it's a cyclic quad if you don't know what a cyclic quad is. Now, by a cyclic quad, we are simply looking at a four-sided shape where all the four vertices are touching the circumference of the circle. So whenever you are doing Euclidean geometry, look out for a four-sided shape. All the four vertices must actually be touching the circumference of the circle. If one of them is not, then it's not a cyclic quad. Now, in this instance, we have CEFD, that is CEFD. We need to prove that it's a cyclic quad. So, there are many ways that can be used to prove that it's a cyclic quad. The first one, we can show that the opposite angles, for instance C1 and F, are adding up to 180 degrees. The next one is the possibility of an exterior angle being equal to an interior angle. The next one could be the angles in the same segment, that is the wedding bow tie. If you remember the wedding bow tie, that is very, very important also. So you look at all the different ways of proving a cyclic quad, and then you screen to take or consider the one that is going to suit in your situation. And more often learners fail to start the problem because we don't have any marked angle. So what can you do? It is also a flexible question. You can start by marking any angle of your choice. For instance, I am going to start by marking C1. So if I let C1 to be equal to X, let C1 be equal to X, I have chosen angle C1 and let it to be equal to X. So in other words, I'm asking myself a question: if I can prove that the addition of C1 and F gives me 180 degrees, then I have proved that it's a cyclic quad. So I need to travel from C1 until I come back to F and then reconcile the two to give me 180 degrees. Now, if you consider the cyclic quad that is originally given, that is A, B, C, D, angle C1 is also equal to angle A. This is the exterior angle of the cyclic quad. So you can see that this is outside and this is the inner one. So which means this one is also equal to X, and then I write X there. Now, it's also very interesting to note that we have been presented with two parallel lines, that is AB and FE. Now, when the question is presented, these two lines are presented in such a way that they are far away from each other. Therefore, the ability to recognize that the two lines are parallel will have slim chances. So, please take note, there is nothing that is hidden here. The two lines AB and FE are parallel. So when they are parallel, we are going back to the fun where we look at co-interior angles, where we look at vertically opposite angles, where we look at corresponding angles. So if you can check angle A and F, they are all in the fun, and in this instance they form co-interior angles. So we can note that F is equal to 180 minus X. Where is the X coming from? F is equal to 180 minus this X at A. So you write there co-interior angles. co-interior angles. It's also necessary to mention the parallel lines. We have AB parallel to FE. Right. Now, we have established that C1 and A are the same, and then also F is equal to 180 minus X taken from A. Then the next step, we now have C1 and F, which has been established as 180 minus X. If we are to write it in the diagram there, 180 minus X. Next step, if we are to add algebraically, let's see what will happen. C1 plus F is equal to our C1, we say it's X, and then our F is equal to 180 minus X plus 180 minus X. This will be equal to X minus X, that's 0, and then we remain with 180. So it means that if you add C1 and F, it gives us 180 degrees. So this confirms that C1 and F adding to 90 degrees and CDFE is a cyclic quad. But when you state the reason, it is very important to note it as follows. Therefore, CEFD is a cyclic quad. And why? The reason is converse. It's very important to mention the word converse because you are working in reverse of the theorem. So converse, opposite angles of a cyclic quad. And then you have proved that A, B, C, D is a cyclic quad as well as C, F, D, C. Okay, thank you.